Hello, everyone. My name is Jay Conrad. Today, I'm going to be telling you about, I'm going to tell you the story of how Go editor support was implemented for Bazel workspaces. So you already heard about Java and VS Code yesterday and IntelliJ just now. So I'm really glad we're talking about editor support at this conference. It's really important. Before we get started, a bit of my history with Go and Bazel. Today, I work at Engflow as a software engineer. We do remote execution. You've heard about that already. Previously, though, I worked on the Go team at Google, where I worked on the implementation of Go modules, fuzzing, Rules Go, Gazelle for Bazel, a bunch of other things. This talk is mostly going to be about that team's work, together with many people in the Go and Bazel open source communities. So before we get to Bazel support, let's go back in time, like 6 years or so. Learning the history of a project, I think, is really important, and in this case, a whole ecosystem. It's a great way to understand how things got to be the way they are and really why they were built the way they are. So most Go code was and still is built with the Go tool. It's a dedicated build system that ships with the Go tool chain. And at the time, the Go tool used a very simple scheme for organizing packages, the GoPath environment variable. GoPath was simply a list of directories. So when you import a package with some path, the Go tool looks in each GoPath directory for a subdirectory that matches that path. And so that logic was really simple to implement. It was easy to write tools on top of, and there were a lot of small command line tools written for many different purposes. One more, yeah. So several are listed here. There are many, many more. I tried to pick a variety for you. So you have static analysis, refactoring, fuzzing, documentation, a debugger, like a little bit of everything. Some of these tools stood on their own, but many were used in editor plugins to implement basic features. So if you were setting up Emacs, for example, you'd install a bunch of these tools, and if you were setting up VS Code, then the plugin would install them for you. But either way, the editor would delegate basic functionality to these programs. So for example, GoDef here, it's a nice simple example, was used to implement GoToDefinition. So you run this program, like it's just a command line tool, you give it a file name and a byte offset into that file, and it will tell you the file location of a symbol's definition. So you don't usually run this directly. Your editor runs it for you whenever you press whatever key is bound to GoToDefinition. And a bunch of other things work that way. So let's talk about what Bazel editor support was like back then. RulesGo got started at the end of 2015, the same year Bazel was open sourced. I started working on it in 2017. So there was essentially no editor support for Bazel, at least not directly. But if you organized your code the same way that the Go tool expected with GoPath, the tools would work kind of okay. So everyone using Bazel outside Google was pretty happy. Folks inside Google exporting code built with Blaze were less happy. Blaze has a different set of conventions for organizing Go code. For example, it allows multiple packages to be in the same directory. The Go tool does not allow that. Interesting fact that Blaze support for Go predates the Go tool. Just weird evolution of languages. So whichever of those worlds you lived in, you have a difficult time working with generated code that wasn't checked directly into your repository. So for example, pb.go files generated by Go proto library. So you wouldn't be able to see that code in your editor since it might not be generated yet. And even if it was, it's going to be in some like Bazel internal directory. Who knows where? The tools certainly don't. And any tool that depends on type checking would also stop working because without those files, you don't have the code that goes with them, and the tools can't figure that out. So Go developers usually ended up checking in their generated code to get around that problem. And if you're a library developer, you'd also want to do this for compatibility with the Go tool, which has no support for build time code generation. So you're probably going to be thinking, like, if I can't generate code during the build, like why would I use Bazel? What advantages does it have? So there were a couple neat things. The biggest was probably caching test results. The Go tool didn't used to do that. Every time you ran Go test, it would run the test over again, even if nothing had changed. And of course, Bazel has remote execution, which was a big thing, but it wasn't quite a healthy ecosystem back in those days. So like people didn't really see that advantage in practice. So the Go tool got better. There were fewer reasons to switch to Bazel. Like we had problems. In 2018, we got Go modules. Modules are a versioning and dependency management system built directly into the Go tool. So now instead of GoPath, you have a go.mod file at the top of your project with a list of dependencies and the versions of them that you require. So this was a totally different approach to file layout, not simply a scheme to copy files into your GoPath or your vendor directory, equivalent to third-party. Modules were essentially a new build system and required like all of the updates that go along with that. So the Go tool needed to parse go.mod files, select which versions to use, download files at those versions if they weren't already in the module cache, cryptographically verify those downloads. And this is all just in the simple case. There are a bunch of other things that you have to do if you're changing versions. It's too much to re-implement for every tool out there. And it's even hard to do all of that in a library. Like we just did it in the Go tool, and we were changing it often enough that we didn't want to provide a library to do it. So none of the tools worked. We had a list of about 50 that we wanted to migrate or rewrite or replace. Really, our goal was to make sure that all of the editors continued working in projects that used modules. And while we were doing this, we needed GoPath to keep working because this was like a long multi-year migration. Like some people migrated early, some people migrated late. And at the same time, we wanted to support Bazel and Blaze within Google, and maybe Buck and whatever else came along, right? And this is all on a team of like 9 people. And all of these people have multiple responsibilities. So how can we get that done in a realistic amount of time? We can solve any problem by introducing an extra level of indirection. I like this quote, and when I was writing this talk, I wanted to find out who said it and why. I like history of things. And I found out David Wheeler here said this in 1951. He is the inventor of the subroutine. So I had to just like stop a moment and reflect. Like you're writing your assembly code or maybe just like raw machine code on like punch cards in 1951, and you're like, aha, we could have functions like abstraction. Like I just wonder what it would have been like to write code back in those days. Certainly weren't worried about like modules and dependency management and editors. So let's get into what we actually built. I'm going to show you kind of a roadmap, just like an overview, and then we're going to go into detail on each part. So starting at the top, we have our editor plugins. These are usually Go-specific things that users interact with directly. So it's our public interface. There are a lot of editors, and so these plugins need to be as small and simple as possible, just doing like whatever's specific to each editor. Each of these plugins communicates with GoPlease, our implementation of the Language Server Protocol, LSP. LSP was developed by Microsoft for VS Code, but it's used by a lot of other editors too. So that server, GoPlease, implements all of the editor features for a language like Go without being tied to any specific editor. Go server is called GoPlease, by the way, as in go please do this for me. But within our team, we'd affectionately call it Gopples. I'm probably going to slip at least once later in this talk and call it Gopples. On a really bad day, once I heard someone call it Gopless. So creative pronunciation. Most of the interesting logic is in Gopples, go please. But we don't want to hard code support for every build system in there. And there are a few other tools besides editors that can use some of this functionality. So for example, if you're writing a code generation tool like Wire, Wire produces code for like static dependency injection. You really don't need any editor support for that. So we have another layer of abstraction below. It's our package loading library. our package loader has built-in support for working with the Go tool, but it can also delegate to other build systems. So it can use an adapter. And so below that, we have Go Packages driver for Bazel. The Bazel implementation ships with Rules Go, but you can write your own implementation too. I don't know of any other open source implementations. I think there might be a Buck implementation. I heard someone mention that at some point. So finally below that is Rules Go, which emits package metadata for every Go library that you might be working on. And that gets collected and reformatted by Go Packages driver. So we're going to do a quick demo. I think this is more fun to see it in action. Hopefully the live demo gods favor me today. Well, maybe in a minute. It got really, really small on my screen. Let's see if we can make it bigger. Yeah, that's all right. Okay, so what I have for you here is I took the gRPC Hello World proto example, and I wrote like a really small Go server around this. So if we scroll down, this is the entirety of my code. It just like takes a request and says like, hello, your name, salutations. And you can see my project structure over here on the side. We have like one file, server.go. There's no go.mod file, so this is not a Go modules workspace. You see our build and workspace file for Bazel. And this is not in GoPath either. And if we scroll up here, we see these red squiggly lines for the gRPC library and for the generated code for our proto. Our editor is unhappy with us. It doesn't know where to find these packages because it hasn't been set up with Go Packages driver yet. So we do what any reasonable engineer would do, and we Google how we can set that up. So we find this wiki for Rules Go, and it has editor setup instructions. So step one, install Go please, but we're using VS Code here, so we can skip that step. It does it for us. Step two, create this launcher script. I'm just going to copy the code and start a terminal here. We're going to make a file directory, create that file. Paste that in there. Make sure it's executable. Okay, what's next? There are some instructions for different editors, but I'm going to copy the VS Code configuration. There's a lot in here. We're just going to go with the defaults, which will work fine. I realized something wrong with my screen is like I can barely see that. I'm sure you all can read that, right? Totally legible. Okay, so we're in settings, workspace. We're switching over to JSON mode, and we're just going to paste this in and save it. We'll switch back over to our file. Sometimes this takes a few seconds to set up, and I was actually hoping that would be the case, but it was very fast this time. Sometimes what you'll see is the colors will switch a little bit, and that's because the VS Code plugin just has like a fallback mode where it uses regular expressions to do syntax highlighting. But when it's working with Go Please, then it has semantic highlighting, and it will use different colors for like unused variables and constants and so on. So I can see that some of these symbols are green, which I know means that the semantic highlighting is working. So let's try a few things. I'm going to select a symbol here, totally at random, not carefully prepared. I'm going to go to hello request here, and you can see this hover is working. I'm going to right click this, and I again realize totally unreadable, but go to definition. So this is a type definition, and it's inside our generated code. And you can see at the top, it's somewhere in Bazel's internal directory. So our editor knew where to find that and knew to build it and knew where to look. Let's try another one. So gRPC new server here. Again, I'm going to go to definition. And this is code that's outside of our project. This is defined in a Go repository workspace rule. So this is like downloaded from the internet, extracted again into some Bazel directory, and our editor knew where to find it. So that gives you an idea. Like finally, this is useful again, and we can move around. We can be productive, and we don't have to be distracted by the lack of editor support. So let's get down into the details now. We're going to start at the package loading library, and we're going to work our way down, and then we'll go back to Go Please and VS Code Go at the end. So let's think for a moment, what information does Go Please need to work? In order to find a definition for symbol, the editor needs to parse and type check a package and everything that it imports. To draw those red squiggly lines, Go Please needs very thorough parsing and type checking. And in fact, Go Please uses some of the same libraries that the Go compiler does. It literally is the front half of a compiler. So as far as like our build system support goes, we can't take any shortcuts. Like we have to be very accurate. So first, given a file name, we need to know the identity of a package that contains it. And in this case, package, I mean the Bazel target, the Go library, or the Go proto library, or anything else that's compatible that produces a Go package. For a given package, we need some metadata. At minimum, we need to know a list of files that the package contains, and we need to know all of the imports from the package. And given one of those import strings, like gRPC here, we need to be able to find the package that corresponds to. So here's the API, that package loading library. We start with a configuration, and that has the current directory, the environment variables, Bazel flags, a couple other things. We pass that to the load function, which is really the only function that's interesting in this package, together with a list of patterns. And each pattern is the name of a file or an import string identifying a package. And import strings, by the way, can also contain like these ... wildcards. So this can be used to load everything when we need to do that. And that returns some of these package structs. Each package struct has the package's Bazel label, that's the ID there, its import path, list of source files, imports, all mapped to other packages. So we get this nice metadata graph. I'm leaving out a lot of detail here. These are just the highlights. For example, you can ask the load function to load the syntax tree and all the type information after it gets the package metadata. And that's really useful if you're writing a command line tool. Go Please doesn't use that. It has its own stuff that it does. So the load function can delegate to Go packages driver. I mentioned that earlier. There is such a binary in rules Go. We had a wrapper script around it to make Bazel build and run it for us. To use that binary, you set the Go packages driver environment variable to the binary's path, and when load is called, it runs that program. The arguments passed to Go packages driver are the patterns given to the load function. The configuration is encoded as JSON and passed through standard in, and the packages are written as JSON and standard out. So I kind of just told you about a lot of plumbing. How does this actually work? So the driver maps command line patterns to Bazel targets using Bazel query. For each pattern, it produces an expression that can be used in the Bazel query language, and it combines all those together. It runs Bazel query once, unions the outputs. So we have a list of targets, at least. Next, the driver builds all of those targets using an aspect. And I know many people have mentioned aspects earlier, and I apologize to the beginners in the audience for the jargon. If you haven't seen aspects before, it's a bit of Starlark code that you can use in Bazel's analysis phase. It's kind of like a rule. Actually, it runs almost on top of rules. It runs on each target on a subgraph of dependencies, and it recurses through certain attributes. And in this case, we're recursing through depths, our dependency graph. An aspect can read provider metadata. Provider's like a little object that rules can return and pass to each other that contains metadata about whatever they analyzed. An aspect can return its own providers. It can declare new output files and actions. So Go packages driver does all of these things. For each target, it reads the Go archive provider. We'll see that in a second. And it writes a JSON file. It also builds generated source files and type information that might be needed by the editor. So Go Packages driver reads all of those files. It knows where Basil wrote them, and it processes them a little bit and then just prints them on standard out. So for example, a little bit of processing. An aspect can only deal with relative paths. Rules and aspects don't get to know absolute paths because they're going to be different on every system, and rules don't get to know those differences. You need the output to be cached. But the editor absolutely needs to know absolute paths. And so we need Go Packages driver to fix things up a little bit. So now we're at the bottom of the stack, at least as far as we're concerned for editor support. RulesGo does not need to do anything special. That's kind of the cool thing, other than like have Go Packages driver be part of the project. Each Go compatible rule already emits a Go archive provider, and that contains all of the metadata that the editor cares about, plus a bunch of other stuff. So specifically, we're caring about name, import path, list of sources. So now we're going to work our way back up to GoPlease and VS Code. As I alluded to earlier, GoPlease is a standalone program that runs in a separate process from the editor. It communicates with the editor using language server protocol, and that sends JSON requests, responses, and notifications over standard in and standard out. And that lets GoPlease be decoupled from any specific editor. When GoPlease starts, it builds a graph of packages, of all the packages in the workspace. So this is kind of like IntelliJ's like indexing thing, like the same kind of thing, except we don't actually have visual feedback like a progress bar or anything. That would be nice. So building that graph means that it needs to ask the package loading library to give it metadata for all of the packages. And once that's done, GoPlease can load diagnostics for any package. And that mostly means parsing and type checking and showing you the errors. This process is lazy, so it's only done for a package on demand, like when you're looking at it. But keep in mind, you need types for one package, then you need types for everything that it imports to. After GoPlease is started, the editor can send it commands like definition. Command requires a response. To locate a definition, GoPlease looks in the metadata graph for a package containing the current file. And then it iterates through the symbols and it finds whichever symbol is under the cursor. And that symbol has a reference back to its definition. And so GoPlease can respond to the command with the definition's location. Most commands can be implemented pretty simply once we have all the information there, like this. Ooh, let's go back one, sorry. The editor can also send a notification like did change. Did change is sent, it means the user typed something. GoPlease doesn't actually watch the file system for changes. The editor has to tell it whenever anything happens. And so these two processes kind of need to stay in sync like this. When there's a change notification, GoPlease needs to invalidate some of its state so it can be reloaded later. So of course, this all sounds like a lot of work. How can it possibly be fast enough to use interactively? Like we're essentially compiling a package, possibly many packages, and we're doing that like after keystrokes, right? So it has to be really fast. To begin, Go is a language with a really simple syntax and few features, and that's really an advantage here. GoPlease leans heavily on the parser and type checker being highly optimized. Parsing in particular is really fast. You can parse a typical Go package, depending on the parsing mode, in tens of microseconds. Super fast, barely even worth caching in memory. There are a few tricks beyond that though. First, GoPlease has this concept of a snapshot, which is a view of the workspace at a particular point in time. So all of the file contents, everything is built on top of this. A new snapshot is created after the user typed something, but only after a short pause, not after every keystroke. There's some debouncing there. You might have to like wait a half a second or something. The package metadata graph and the type information for every package are computed based on a snapshot. And each snapshot, in order to be efficient, reuses as much information as possible from the previous one. So to borrow a functional programming term, this is a persistent data structure. You may also know that as like a copy on write type of thing. So in particular, we want to avoid reloading the package metadata graph after every change if we can, since we have to call the package loader and that takes a while. That only needs to be done after a change that might affect it, like adding a new file or changing the imports somehow. We, in particular, don't need to reload the graph after like typing in the interior of a function or like changing a comment or anything like that. That's definitely not going to affect other packages. Underlying all of this is a generic, no, here we go. Underlying all of this is a generic in-memory cache for reusing results of deterministic functions. I'm going to be really vague about this because it can be used for just about anything in GoPlease. The keys to this are hashes of all of the inputs to the functions, and the values are whatever the outputs are. For example, we certainly want to cache diagnostics and type information. So this probably sounds kind of familiar to you. It's very much like Bazel's action cache, which takes the hash of a command that you want to run and all of its inputs, and hopefully if it's in the cache, it will give you a hash of the outputs, which you can look up. And that turns out to be a really good analogy. GoPlease is essentially a fast in-memory build system. Very specialized, but the patterns are still there. Let's take our last step up the stack to the Go extension for VS Code. This is a pretty small one, so I'm just going to kind of share some quick facts. There are a lot of editors that use GoPlease, but I'm going to pick on VS Code in particular because it's the most popular. IntelliJ and Golang, also a very close second, but they have their own implementation of everything. It's all written in Java. I don't know anything about it. Vim is the next most popular, and then Emacs and a long tail of others. VS Code Go was originally written by folks at Microsoft, and the Go team worked directly with them during the modules transition, and then eventually adopted the project entirely. Like most VS Code extensions, this one is all written in TypeScript. I've heard TypeScript is a great language. I've never actually written more than a line or two of it, but of course Go prefers to write in its own language, and that's a really good thing because we get to keep the extension nice and small, which is what we want because there are a lot of them. The purpose of an extension is to integrate into the editor and expose Go-specific features to that specific editor. So it's kind of like a binding layer. So VS Code Go is responsible for installing and updating GoPlease. It also works with a couple other tools like Delve for debugging. Debugging is a whole other topic. VED is a static analyzer. There can be other static analyzers used, and a bunch of other stuff integrates. VS Code Go provides like other Go-specific functionality, key bindings. It can like upgrade or downgrade modules if you're using modules. It can help you with a bunch of other stuff. So that's pretty much it. I'm going to wrap up here. I hope you found this interesting, but actually, I hope you found this inspiring. I wanted to give this talk because editor support, I think, is really important, especially for people who just want to get their work done. Like, they're not in this room because they don't really care about the build. The build is just a tool, and when the build causes the editor support to have red squiggly lines everywhere, it's really frustrating. So if you want to help out for Go specifically, I wrote some resources here. Rules Go, of course. Go for Slack is a great resource. I should have put it on the slide, but Bazel Slack, shout out to that. Really fantastic place to ask questions and collaborate with people, the Go project itself. If you work in another language, please steal all of this. We went through like 8 or 9 different design iterations, like figuring out how many layers there should be and like where exactly to carve the seams. I hope you don't have to reinvent the wheel, or if you do, and have a good time doing it. Maybe this is an inspiration at least. And last thing before I go, I want to thank everyone who worked on this. One thing, I don't know if this came across, but a lot of people worked on this from a lot of different companies. Some large like Google, Microsoft, some small, just like anyone who felt like contributing to this or like before modules or anything, like anyone who wrote like GoDef or any small little tool. Seriously, thank you to anyone who worked on all of these things, made a lot of people's lives better. It's very much appreciated. I especially want to thank the people who took over maintainership of Rules Go and wrote a lot of this. Thank you all. And thank you to my audience and everyone, all the organizers and tech crew. Thanks.